Hello and welcome to this video on Spark procedures in BigQuery. Today I would like to explore ways to develop, test and deploy PySpark code using BigQuery Studio. Every day when building modern data pipelines, data professionals encounter increasing data volumes and processing demands. Spark procedures is a powerful solution to enhance BigQuery capabilities by leveraging Spark in-memory processing and custom logic. In this video, we're going to have a look at the setup components, create and run procedures from PySpark and SQL query editors, make use of parameters, set requirements to use custom service account, and deploy Spark procedure on a custom image. Spark procedures could be viewed as user-defined functions written for Apache Spark that execute within a Dataproc cluster. It extends BigQuery capabilities by enabling potential cost savings by offloading heavy processing to Dataproc, improved performance for computationally intensive tasks, ability to handle complex data structures and algorithms not natively supported by BigQuery. To work with Spark procedure as an admin or a user, make sure you have required IAM roles assigned. Google provides detailed information about required IAM permissions in the official documentation. Here, you can find required predefined roles, as well as the list of permissions required to create BigQuery Spark connection or create or call procedures for Spark. A few words on Dataproc Persistent History Server. PHS provides web interfaces to view history for jobs that run on active or deleted Dataproc clusters. According to GCP documentation, PHS is available in Dataproc image from version 1.5 on and runs on a single node Dataproc cluster. One of the limitations of PHS is that its cluster image version and the Dataproc cluster image version need to match. It means if you use a Dataproc 2.0 image on your PHS to view job history files of your Spark jobs, you need to use Dataproc 2.0 image on your job clusters as well, and locate them in the project where the history server cluster is. To preserve the Spark procedure's run history, you would need to reference the PHS cluster when creating a connection from BigQuery to Apache Spark. To create Spark connection, you need to have a BigQuery connection admin role on the project. Connection can be created either from the GCP console or using a BQ command. For our example, let's use the BQ command. Connection was successfully created. Now let's add the IAM permissions it needs to execute Spark procedures. We've successfully added roles to the Spark connection service account. Note that roles assigned in this example are for demo purposes. In prod environment, IAM policy should be carefully reviewed and evaluated depending on the use case. Now, as our connection has permissions to do what we need, let's wrap up the setup and dive into running some Spark. Let's have a look at our first Spark procedure. We're going to run it directly from the PySpark editor. In order to do that, we need to specify the Spark connection and store procedure invocation settings, as well as provide Python code itself. In this example, we're going to load the data from a CSV file in GCS. Spark is expected to read the file, check data frame columns, hash email columns, and load the data to the BigQuery table. Further in the code execution function, you can see that Spark session is created, data in columns with email in the name is hashed and added as a new column, load time column is created and populated with a processing timestamp. Let's see how it works now. Procedure was successfully executed with the data loaded to the BigQuery table. Let's move on to the next example. Let's consider how we can create a procedure with parameters. Variables defined in the previous example shall become parameters now. Also, we are going to set a procedure to run with a custom service account instead of the one associated with a Spark connection. Procedure is successfully executed. Data was loaded. Let's check out how the SQL query editor works now. To continue our journey in the following example, we are going to create a Spark procedure using SQL query statement. As you can see from a create statement, we have defined the procedure name, expected parameters, Spark connection, and options. Options define a runtime version and provide a link to the Spark job main file in GCS. Language is set to Python. Note that according to Google documentation, if the body of a stored procedure code is more than 1 megabyte, it's recommended to put it in the file in the cloud storage bucket instead of using inline code. Let's have a look at the Spark job main file from GCS. As you can see from the code, Spark job expects 6 parameters to run, defined as environment variables. So, everything looks good. Let's get back to our procedure statement in BigQuery and run it. Great, procedure got created, so let's invoke it now. In order to do that, we need to declare required parameters and call the procedure, supplying declared parameters as arguments. The data was processed and loaded to the BigQuery table. Let's have a look. Our table got created, data was loaded. Let's move on to our final example. Now let's try to run procedure as an inline code using a custom image. In this example, we're going to perform encryption, which requires additional libraries not installed on the default Dataproc image. Therefore, we need to build our own with pre-installed libraries and push it to the artifact registry. Google documentation provides an example of a custom container image. To build one for our Spark procedure, we're going to add required libraries to the code, build an image on Docker, and push it to the artifact registry. Our custom image is now stored in artifact registry. Let's move on to create a procedure in BigQuery now. Let's have a look at procedure create statement. Custom container is defined in the options. To pull the image from the artifact registry, make sure service account has access to it. Farther down, we have the code for the Spark execution. We have defined function pulling an encryption key from secret manager to UDFs to perform hashing and encryption. We provide a list of columns to hash and encrypt. Email column should be hashed, while last name and first name columns should be encrypted. Source data is obtained as a SQL query. Spark session is defined with a few properties. When hashing and encryption are performed, the result is written to another BigQuery table. For simplicity, we won't define parameters here, however, it can be done as demonstrated in previous examples. Spark procedure successfully executed. Data was successfully processed and loaded to the BigQuery table. As we can see, first name and last name were encrypted, email was hashed, load time column was added. This particular use case could be interesting if you're working with PII data. When dealing with big volume, offloading encryption to Dataproc can save a lot of time. Throughout the video, we discovered how Spark procedures extend BigQuery capabilities, handling data processing not natively supported by BigQuery. At the end, I would like to share my own impressions after spending some time working with the Spark procedures. Offloading heavy processing from BigQuery to Dataproc can offer a considerable benefit of cost savings, as well as improved performance for computationally intensive tasks. In other words, for example, if you work with PII and need to encrypt big data volume, it is both computationally intensive and not natively supported by BigQuery. This is where Spark procedures could be a potential solution. If you're running out of BigQuery slots handling complex ETL transformations, you could use Spark procedures instead, potentially lowering the cost of the operation. Spark procedures can be conveniently created using PySpark or SQL query editors in BigQuery Studio. It provides various opportunities for a great number of use case scenarios. Passing input-output parameters allows code reusability, simplified interaction, code optimization, and flexibility. Use of custom containers and service accounts opens up the possibility to pre-install required libraries and control the use of created procedures. That would wrap up our today's episode. Thank you for watching. I hope you have enjoyed the content and see you next time.